Hello again, everybody, and welcome to the second in this series of short videos that I'm doing to put forward an alternative, radical but logical alternative to the standard model of both quantum physics and cosmology. The first video I did was basically an overview and giving background into why I started composing this hypothesis, and also the reason why I published it in a small book rather than doing it as a scientific paper. Anyway, I explained all that in that video, and I don't want to spend time on that now because I want to make these videos consist of the important things that I want to get over. Only so many YouTube videos you look at start off and then they go through the whole history of who come up with what and everything else, and it's not necessary. You don't need it. We need to look at the problems that we've got now and find logical answers to them. So anyway, what I'd like to do in this video is try to give a comparison between the standard model description of the atom and what I propose in my hypothesis. Now, I'm sure that most of you will be aware of the standard model's description, which is basically what they call the Bohr model or the planetary model, where the nucleus can be sort of thought of as like our sun, and the electrons like the planets and that revolving around it. Anyway, this model, although is said to be okay to give students a general idea of how the atom works, in reality nobody's got a clue of how the atom works. Nobody has ever seen any subatomic particle, let alone, so all the particles that make up the standard model table of particles basically are only conjecture. All we can say about them is that they are pieces of atomic matter that's been smashed together in colliders at enormous speeds and pressures, and all the bits and pieces that fly off that have been traced, and depending on what parameters these pieces are, what electrical orientation they've got or the size, will determine what particle they say it is. So anyway, my model of the atom is completely different from that, because I maintain the cornerstone of my hypothesis is that absolutely everything that exists in the universe is composed of just two incredibly small monopole particles. And these particles, one's positive and the other one's negative. And I maintain that they have either a repulsive or an attractive force to their opposite particle, attraction to opposite and repulsion to like. Anyway, the problems I've got with the standard model of the atom is there are a number of things that stick out like a sore thumb that don't make sense. And one of them is the enormous empty space between the nucleus and the so-called electrons that are supposed to be, spinning around it. I won't go into specific figures because it doesn't really matter, but roughly speaking, the nucleus is something like 200,000 times smaller than the outer boundary of the atom, and the electron is some 2,000 times smaller than the proton, which is held in the nucleus. So there's a vast empty space between the nucleus and the electrons. And to have that empty doesn't make any sense. What I'm proposing in this hypothesis as I go through is that that empty space is actually filled with the negatively charged particles, and that could account for the missing mass of the universe, for one thing. This is where I say one thing relates to something else. So although I'm talking about the atom, this applies to the whole of the universe. Anyway, another problem with the standard model of the atom is that the electrons are said to be orbiting the nucleus, and because they're of opposite charge, realistically they should combine together, the electrons and the nucleus. Now it's argued they don't because they're revolving around the nucleus and they've got angular momentum, or this centrifugal force, and because of that they stay out in their relative orbits. So my argument is that from standard physics, classical physics and engineering, we know that any form of motion requires energy, and any form of energy exerted on something to produce work, a byproduct of that is heat. So it's also said that the electrons cover this whole area. There's a probability factor that the electron could be anywhere at any time. So, if in the case of a hydrogen atom, they say there's one electron and one neutron in the nucleus. So for one electron to cover that vast distance in area would mean that it'd have to be whizzing around at God knows what speed and changing trajectory all the time. And to do that, it would be exerting energy, or consuming energy, in which case it will be emitting heat. So under that scenario, every atom would be generating heat, which plainly it's not. Another point is that from the experiments they do at CERN, the collider at CERN, they say that if they cool atoms down to a really low temperature, the activity of the atom slows right down. So if it slows right down, then the angular momentum of that electron will be lost, and therefore it will drop into the nucleus. It's a bit of a Heath Robinson lash up I'd done earlier on to try to explain it. I've got a spring there on a bit of strumical, pushing a nut against. The chuck represents the nucleus, and this little darling here represents the electron. Now I was going to start whizzing something around, but I thought I'd better not do that because something will come flying off and I'll get into trouble. So this is bad enough. I'll try this. You might be able to see it, you might not, but just to get the general idea. If we go slow, it stays right by the nucleus. If we speed up, it flies out. Now as it slows down, which would happen if they cooled the atom down, the electron would combine with the nucleus, making the whole system unstable. So all these things come down to basically write off the standard model of the atom. So I've come up with an idea that suggests a way of accounting for the positive and negative sides of the atom, whereby the negative values, which would be represented by the electrons, are combined with the nucleus, but the atom still would work in the same kind of way that we found is acceptable in physics. So what I maintain is that these two monopole particles form the nucleus, and each element, each atom, whatever element it is determined by how many of the positive particles are contained in the nucleus. Now, I didn't mention this time, but with my model, there is a massive imbalance between the positive and the negative particles. The negative particles massively weigh out the number of positive ones, and the positive particles will only be found in matter, in the material that we know of ourselves, the fireplace behind me and everything. So baryonic matter, as it's referred to. So you can't have the positive particles on their own. They're always encompassed with negative particles, because in my hypothesis I maintain that the negative particles form a cloud and fill every available space throughout the universe. Now, in the nucleus, I contend that the positive particles, when they were being formed, are immediately encompassed by negative particles. And as these aggregate together to form clumps, the different atoms are formed, the different elements. And like the hydrogen atom is said to have one proton and one electron, well, I say that, the hydrogen atom is probably the smallest atom that will interact with light and everything else, and is probably the smallest atom that will be capable of either receiving or emitting a photon. So if you can imagine these particles clumping together in the nucleus like that, but their charges extend beyond the physical size of the particles, so that they don't lose their charge. So as these particles clump together, they're still attracting other particles. But add to that the negative charged cloud, negative particle cloud, is trying to repel its neighbours. All the particles are trying to repel each other in every direction. So you've got a negative force of repulsion throughout the whole universe. And I maintain, and I describe it in this book, that the negative particles are what is referred to as dark matter. Now, the reason why it can't be detected is because it is of one polarity, and the particles are so small that it's impossible to see them. But the force that they produce is what is said to be expanding the universe, but it's not. I maintain the universe is not expanding. I maintain that there's this negative force throughout the universe, and that also is, the negative force is dark energy. And I also maintain that that dark energy is one of the two forces of gravity, because I believe gravity works in two ways. I believe you've got the attractive force of matter to matter, and you've got the repulsive force of the dark energy, the negatively charged monopole particles, and that's what holds all the planets and all the matter in the universe in their relative positions. If it wasn't for a force holding them apart, everything would clump together. So, in a short video like this, you can't really explain an awful lot. It would be far better if you was in some kind of debate where you could be throwing arguments backwards and forwards and things like that. But it's much easier when it's put down in a book. Even that is very scant. You can't go into immense details on it. So basically, I maintain that the way the atom works is the electrons don't actually exist as solid fundamental particles. I believe that as the positive matter clumps together to form atoms, to form the nucleus, that the negative particles are still trying to get into that nucleus, and they can't. So where the two forces reach equilibrium, that will be the boundary of the atom. And the only energy transfer between atom and atom will be by what is described as the photon. And I would suggest that the photon is basically either a clump of these negative particles, but more likely to be a positive particle that is encompassed by negative particles to form a clump. And I believe it's that energy that passes from atom to atom. In my description, I explain how isotopes can form, how it doesn't affect molecules forming, and it's a system where you haven't got to rely on the fudge factors of, like, the exclusion principle, where the electrons aren't allowed to exist in, different, but only allowed to exist in certain energy bands, or the uncertainty principle and probability theory. This gives a direct, logical account of how the atom can work that will still fit with classical physics that we know and we can prove. In all fairness, the only way that you can uphold most of the quantum mechanics and cosmology these days is with complicated mathematical equations that basically you can chuck them out the window because they don't mean anything, because they're all based on supposition. So instead of doing that, it's sensible to go back to square one and say, right, we know there's lots of problems with the standard model and it's not working. So why is it that when you've got all the wonderful brains that we've got, and these people are clever, the physicists are clever, but basically they're mathematicians, and what they argue over is different form of mathematics. You need engineers to think about this and to come up with sensible answers. And like I say, you think about all the thousands and thousands of brains that have been working on this, and now all the AI, all your computers, and they still can't come up with answers. They can't answer gravity. Now, I honestly believe that gravity's got nothing whatsoever to do with curvature of space. You see, I'm wandering off onto another thing now, which is not right. But as I say, it's all in this little book. And what I said in my last video was, have a look at this. This is available on Kindle. If you type in either the title of it, the Two Monopole Particle Universe, or type in my name, Tony Norman Marsh, it will come up. Like I say, I'll leave a link for the first video I've done. And I offer a challenge to anybody, particularly the academic community. Have a look at it, see what you think of it, and prove me conclusively wrong. Or ask me to come to one of your discussions, and we'll argue the pros and cons out like that. The other thing I would ask, if possible, and I know lots of YouTubers say that, and I'm not really a YouTuber, if you do click on this video, could you please subscribe and like? It doesn't cost a penny. All it is 2 little clicks. And also, if possible, can you watch it till the end? Because that makes a difference as well. And if you've got anybody else that you think might be interested, give them a buzz and say, have a look at this, see what you think, and ask them to do the same thing. But hopefully I'll come back with some more. It might all be a bit jumbled, I'm afraid. I'm sorry about that. But when you've got so much in your head that you're trying to get over, it's not the easiest thing of the world just to narrow it down to one specific thing. But I do my best anyway. Best of luck, everybody. Hope to see you again, and look after yourselves. Ta-da! Right, what have I got to do? I don't want to do that.